Okay, so here is notes 2.5. I put a little note here. I'm going to start putting what our actual notes are coinciding with the textbook. You know, the red textbook that we rarely ever open. But if you did like to read there, you could open up 3.3-33-4 in the textbook, and that's going over the same type of stuff we are. Okay, now 2.5 is actually really closely related to 2.6. I'm sorry, 2.4, writing equations of lines. In this case, though, we're going to be able to write an equation of a line that is parallel or perpendicular to a given line. So not only writing an equation of a line given certain information about that line, but that's actually going to be um, more precise about being parallel or perpendicular to that. So just conceptually speaking, here's what they're talking about. So they're going to give you basically the last section that we did, you were given some pieces of a line and you had to write the equation of a line. So now what's going to happen is they're going to give you a line. So let's say this is a line they give you. Now they're not going to actually give you the graph of a line. But basically they'll give you certain parts of this line that's on there. So they might give you the y-intercept, they might give you a slope of this line, something like that. But basically, this will be their line that they're giving you. They'll tell you their line. They'll give you an actual equation of this line. Now, your job will be to make your own line. So let's make a copy of this line. Oh, that didn't work. Oh, wait, yeah, it did. Hold on. Paste. There it is. Okay, so your job is going to be this. You'll have a line here. That will be their line. Your job is going to be if they tell you, hey, I want you to write a perpendicular or a parallel line that goes through the point 2, 2. So there's the point 2, 2 is the point right here, and then you're going to have your line going through the point 2, 2, and if they say they want it parallel, then it should look like this. Now you got to find the equation of that line. So that one line will be your line. So let's make this another color. So properties, make it red. So your line's the red line. Their line's the black line, your line's the red line. So when they have their line there, they're going to say something like, I want a line that's parallel to my line, but it has to go through the point 2, 2. So this would be your line because that's going through the point 2, 2. If they say, well, they want a line parallel to the black line, but it's going to the point -1, -2, -1, -2 is a point way down here, but it should still be parallel, so it should still have the same slope. Um, so parallel lines do have the same slope. I'll go over that in a minute though. Now, if they want it perpendicular, perpendicular lines look like this. They meet at the geometric definition of it is they meet at 90-degree angles. So let me try to make this 90 degrees. So they're going to say, okay, the black line is theirs. They're going to want a line that's perpendicular to their line, but goes through the point 3, 1. So the point 3, 1 is right here. So they're going to want something like this, and then you're going to have to find the equation of your line. So that's actually one way you can do this is if you had a graph, you could actually graph your own line meeting the requirements that they want. But I want to show you how to do this algebraically because, as I've told you before, unless you have really nice graphing tools, many times graphs tend to be inaccurate, which will make your answer inaccurate, which will make you wrong. So just a quick thing about parallel and perpendicular lines. So you've been over this in Algebra 1 and Geometry. The main thing we want to get from this is that parallel lines end up having the same slope. So if you have two lines and they're called parallel, they have the same slope. So let's say that their slope is m equals, I don't know, 5/2. Okay? That means your slope would have to be 5/2 also. So you would have to have the same slope. Now, as far as the points that they actually go through, like the example I was showing you over here, the points that they go to don't have to be the same points, but the slopes do have to be parallel, so they will look like this. Analogy there would be like train tracks. Okay, perpendicular lines have opposite reciprocals. Reciprocals. Pretty sure that's how you spell that. Opposite reciprocals. So opposite reciprocals are basically this is their slope. So if their slope is m equals 5/2, your slope would be, now remember, reciprocal means that it gets inverted. So it's going to be 2/5. Now the word opposite in math is kind of like Most of the time in this case it means a negative. So you take the opposite sign. So opposite reciprocals, opposite signs, and they flip over. So it flips over and changes signs. Okay, so those are going to be the keywords. Parallel means that you know your slope matches theirs. Perpendicular means that you got to take their slope, flip it over, and change the sign. So be careful about where you see those. Now, you're going to be given some information here. One of the pieces of information is that they're going to tell you what their equation of their line is. So in that, if we go back to this thing, they're going to tell you the equation of their line. So if their line is this black line, they're going to actually tell you the equation of this line. Okay? So from that information, you're going to take their slope. So you're going to take their equation, find their slope, and then you have to figure out what your slope is. So if your slope is parallel, it matches theirs. If your slope is perpendicular, then it must be the opposite reciprocal of theirs. And then you just follow the steps that we learned yesterday to find your line. Okay, we're going to go over 4 examples. Let's see if I can get this faster than yesterday. Write an equation of the line that passes through 3, 2, and is parallel to the line y equals 3x plus 2. Now, parallel to this line. That line right here, this is their line. That is not your line. If this was your line, you'd be done. If I said write an equation of a line and they told you this line and it was yours, you just circle this and that would be your line. It's not going to be that easy, okay? So basically what this is saying is their line is this one. That's like that black line on the graph that I just showed you. Now you have to build your line using this information. Now your line is supposed to go through this point. Their line doesn't go through this point. If you think about it, if you plug a 3 into here, negative 3 times 3 is a negative 9 plus 2 is a 7. That's not a 7. So that's not their part of their line. Okay? So y equals negative 3x plus 2, that's their line. Now from their line, we know that their slope is, luckily this is in slope-intercept form, their slope is negative 3. This is theirs. Okay? Now, since it's parallel, okay, our slope is going to match theirs. So our slope is going to match. Okay? So it just so happens that our slope has to match theirs because it is parallel. So now we have a slope and we have a point. So we have enough information to write our equation. Now, I wasn't too specific here. I just said write an equation. So that means that we can make it in any of those, any of the forms that I taught you guys. Since we have a slope and a point, might as well use point-slope form. Okay, so y minus y1 equals m times x minus x1. Reason why I chose that is because, I mean, it's a point-slope form. We have a point and a slope, so it basically fits. So just plug it in just like we did the other day. 3 is your x1, 2 is your y1. Plug that in along with your slope. So y minus y1 is a 2 equals m, which is a negative 3, times x minus, and then your x1 is a 3. And that's actually an equation in point-slope form. Since the directions didn't tell us what form it has to be in, that's it. Now, if they wanted it in another form, you would have to transform it. So if they wanted it in y equals mx plus b, you would have to distribute the 3 and then move the 2 over. If they wanted standard form, then you move the x over, and that was from yesterday's work. Okay, but like I said, it doesn't say that, so then you're done with this one. Okay, next one. Write an equation line through 8, negative 3, so our equation has to go through this, and it's perpendicular, so now it's perpendicular of their line. This is their line. So their line, their slope is 4 over 3. Now keep in mind, I don't know if that's my slope until I figure out what they want. They want it perpendicular. Since they want it perpendicular, I know that I'm not going to use 4 over 3 again because that would be parallel. So I got to flip it over 3/4, and I have to switch the sign because that's what makes them perpendicular, okay? So their slope turns into that. Now this one is our slope. So we have our slope, we have our point right here. Remember, that's x1 and y1, okay? Once again, I didn't get too specific about what form it had to be in, so it can be any form you want. easiest one to do is, once again, we have a point and a slope, so use point slope form. So y minus y1 equals your slope times x minus x1. Because you just plug it right in and that's it. You don't have to do any simplifying. So y minus negative 3 equals your slope, which is negative 3/4, x minus, and then your x is an 8. Not quite done there just because you shouldn't leave a minus negative like that. So clean it up a little bit, simplify it. Y plus a 3 is equal to negative 3/4 x minus 8. This is an equation of the line in point slope form. If you wanted slope intercept form, you would have to do a couple more steps. So let's say it did say slope intercept, because I do want to show this. Okay, if it said slope intercept, you would distribute the negative 3/4, so you get y plus 3 equals negative 3/4 x. Negative 3/4 times a positive 8 is a positive 6. Okay, then you would subtract 3, y equals negative 3/4 x plus 3. And if it said it had to be in slope intercept form, that would be your answer. Okay. Actually, since it doesn't say what your answer is, you could have kept going and just put it into this form and put this as your answer, and you'd still be right. Okay. Example 3. Write the particular equation of a line through 2, 1 and is parallel to the line 3x plus 4y equals 6. Then transform into slope intercept form, then transform into standard form. So they want everything here. Now, particular form, or the particular equation, that's wording that's used in your textbook. I put it like that because the questions I'm going to give you guys at the end of practice are from your textbook. Particular equation, from what your textbook is describing it as, is point slope form. Okay, so it's like the other ones what we just did. This is point slope form right here. So they want you to start off in point slope form. That's what particular equation means, apparently, according to the book. And transform it into slope intercept, and then transform it again into standard form. Okay, so once again, we have our point. That's the point we want our line to go through. And their line. Now, the only difference here is their line, it's not completely clear what the slope is. Now, if you memorized from the last section, we could actually find the slope from this without solving for y. Or you could solve for y, either way. If you memorized it, then it's supposed to be negative a over b is your actual slope when it's in standard form. But let's go ahead and work with this. So it's 3x plus 4y equals 6. So say you forget that. You don't remember if it was a over b or b over c or whatever that is. So let's say you're given in standard form. So if you want to find the slope of it, one way of doing it is to put it in slope intercept form. So you subtract 3x, so you make a 0 there. That goes away because it's the identity equals negative 3x plus a 6. Now we're going to divide both sides by 4. So, whoops, 4 right there. It's a 1 equivalent. 1 times y is y. So it's going to be negative 3/4 x. 6 over 4 is going to turn to 3 over 2. And that's their equation still, right? That's right, Mr. Aguirre. All right, hey, people, hey. Okay, so this is going to be their slope is equal to negative 3/4. So all that work was just to figure out what their slope was, because this was still their line. So I know their slope is a negative 3/4. Now they want it parallel, so you got to be very careful about these wordings here. They want it parallel, so our slope should match theirs. So since it does say the word parallel, we know our slope is going to be negative 3/4 as well. Okay. Now if it said perpendicular, you'd have to flip it over and change the sign. All right, so it wants the particular equation, which is basically what we've been doing. So I'll do this in blue over here. So y minus y1 equals m times x minus x1. Now, if you're wondering why I keep writing the equation out, that's probably one of the best ways for you guys to memorize this equation. This formula is to keep writing it for every problem until you get it down packed. Okay? So plug in. This will be y minus 1 equals your slope, which is negative 3/4, x minus 2, and that is one piece of your answer. Okay? That's basically your answer for part A, if there was a part A. Okay. Then it wanted you to switch it into slope, I believe slope intercept. Let's see here. Yep, slope intercept form. So if you want to do slope intercept form, one way you can do that is do a fraction buster right now. Multiply both sides by a 4. So this will end up being a 4y minus 4 equals negative 3 times x minus 2. Because when you multiply this side by a 4 and this side by a 4, I don't know why I made brackets there. Make sure when you multiply this, the 4 only multiplies to the negative 3/4. Do not multiply it to the x minus 2. Because that is a group of stuff. So we said before that you can think of the x minus 2 kind of like it's a big variable. Please don't draw this gigantic x on your page, by the way, because then you won't know what's going on with your notes. Mr. Aguirre can make it disappear. Go away. See? Okay. Here we go. Keep going. And this is going to be 4y minus a 4 equals negative 3x plus a 6. Add 4. So you're going to get 4y equals negative 3x plus 10. Divide both sides by a 4. Then page. So y equals negative 3/4 x plus 5 over 2. 10 over 4 simplifies to 5 over 2. So that's another piece of your answer. Okay, last piece is standard form. Now, I am okay with you guys using work that you've already done to figure things out, since all of these are equivalent equations. They're all the same. This equation is the same as this equation, is the same as this one, same as this one, same as this one. So since you did all the work already, I don't mind you using one of these steps up here. So looking at this, this equation right here, this step is probably the easiest to turn into standard form. So what I'm going to do, I'm going to use this one to use my last part. So I'm going to start from there. Now you need to rewrite it. 4y equals negative 3x plus 10. You've already done the work to find it up to there, so I don't mind you guys doing that again. So plus 3x, because we're doing standard form now, plus 3x. That's going to be 3x plus 4y equals 10. You now have all three forms. Good job. And moving on. Perpendicular through those points and goes through 0, 1. Write an equation through 0, 1 and is perpendicular to the line through the points. Okay, so this stuff right here, this is their line. Now it's kind of tricky because this line is not your line. These 2 points right here, they actually, this is their line goes through that. They didn't actually give you an equation. So guess what? You get to find their equation and then use this point right here to make yours. So I'm going to do their equation in red. Now, just like yesterday, I start with m, so that's going to be y2, which is a negative 8, minus y1, which is a negative 2, over negative 10 minus 5. This is going to be negative 8 plus a 2, so it's going to be negative 6. Negative 10 minus 5 is a negative 15. That simplifies down to a, what's that, 3, 2 over 5, 2/5. Okay, I'm not done yet. I'm going to go ahead and use their point, which is right here, to figure out their slope. Now I'm going to put in point. Actually, you know what? I don't even got to figure out that. Whoops. I want it perpendicular to their line. I don't really care what their line is because now I know their slope. So I don't got to calculate all that stuff. I know their slope. Their slope is 2/5. I can put it in, find out their entire equation, but remember, I don't want their entire equation. I just want their slope. So I got their 2/5 slope. So our slope, or your slope, whatever, our slope, perpendicular, meaning I take their slope, flip it over. So m equals 2/5. So we got to flip it over, so 5/2, and it should be a negative. That's our slope. Now it should go through this point. Now every once in a while, I'll give you a nice neat point. This is actually a y-intercept. 0, negative 1, that's a y-intercept because x is 0, y is 1. That's a y-intercept, so we actually have an intercept and a slope. So let's use slope-intercept form. Y equals mx plus b. Because once again, it didn't say what form it had to be in. It just said write an equation. Okay, I'll write an equation. So this is your b since it is a y-intercept. So you got y equals negative 5 halves x. And then your b is a negative 1, so minus 1. You're done. Woohoo! Good job. Yay. I'm cheering for you guys. So practice problems. 4 of them. 11, 13, 15, and 17. This isn't going to be due until Monday because tomorrow's our quiz, so I do want you guys studying for the quiz, so this isn't due for a while. But this is on page 91 in your textbook, 11, 13, 15, and 17. I think the textbooks have odd answers in the back, so if you want to check it, you can. So 11, 13, 15, and 17, I went ahead and copied them down for you. If I turn this off too fast, then push pause and then look at it again. Okay. Okay. Yes, Mr. Aguirre. Oh, you're such a nice class. Yay. Okay, so went a little bit over, but too bad. All right. Okay. Bye-bye.